Okay, I think I said in the previous video that in this one I would look at more collat stuff. I'm going to stop that for a second. And in this video, I just want to say a little bit more about Numpy. So the first thing that you might have noticed, this is a consequence of my having messed up the videos on Monday. Before we just had this, and if we wanted to use NumPy, I would have to say, AR equals NumPy dot arrange 1, 10. This is going to give me the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9 in a NumPy array. But having to write NumPy over and over again gets a little bit irritating. So we can use this phrase as in P. And so what's happening is within Jupyter, whenever I use in P, it just interprets it as if I had written NumPy. So I can come down here and write in P instead of NumPy, and if I run that, then I get, now if I want to print the array just to see what it looks like, this is what I get. Okay, so now I want to talk about some of the things that we can do with a NumPy with a NumPy array. However you get it, we've learned there's different ways to make a NumPy array. Let's assume we have a NumPy array, and let's learn about different things that we can do to this NumPy array. Well, one of the most basic things is to just look at one of the elements. So let's say we want to print the third element of the array. So if we want to print the third element of the array, this means the second indexed element, because this is the 0th indexed element, that's the first indexed element, and that's the second indexed element. So I'm going to print 2. Okay, so again, the way that we locate an item in a NumPy array is to use these square brackets. This is standard computer programming notation. But often we don't want just one element of the array. We might want a subset. So maybe we want the first 4 elements. So 1, 2, 3, and 4. Okay, so to do that, we can index an element, and I'm going to say the following. I'm going to put 0 here. We want to go to the 4th element. So the 4th element is the third indexed array. So I'm just going to type this. I'm going to do array 0 to 4. I'm going to run this, and we're going to see what we're going to get. We get the numbers 1, 2, 3, and 4. So what this does is it takes all of the elements from the it takes all of the elements from the 0th index all the way up to the 4 minus 1th index, so the third index. So if I put a 0 there and a 4 there, this is going to take the elements of the array corresponding to index 0, index 1, index 2, and index 3. If I make this a 5, it's going to be index 0, index 1, index 2, index 3, and index 4. So it's going to give me 1, 2, 3, 4, and 5 when I print this out. Okay, but notice 5 is the 4th indexed array. So when you use this thing, it's called a slice. When you do an array, when you have an array and you make a slice, this is going to be, you're going to get all of the elements in the array from this index to that index minus 1. So for example, if I put a 2 here, this is going to give me the array starting at index 2, the third the index 2 item, the index 3 item, and the index 4 item. So this would just be 3, 4, and 5 when I run this. Okay. Now let's say for whatever reason we want all of the elements 0 to 5, but we also want the elements, let's say the 9th and 10th indexed items. Or actually, let's just do a little experiment. So what numbers am I allowed to put here? If I do 9 and 10 and run this, what do we get? Well, nothing, because what's happening is this is looking at, because the 9th indexed item, well, what is a 9th indexed item? Well, there's only 9 elements in the array, so this has index 8. So if I do something like 8 and run this, let's see what I get. Well, it's going to go 8, and so we might think it's going to be the index 8 and 9 item, but there is no index 9 item, so it just gives us the last item, which is 8. And then just to look at this again, if I do 7, okay, so now I'm going to put this as, I'm going to put this back to 9. That's what really makes sense. Okay, and let's say for whatever reason, I want an array that consists of items 1, 2, and 3, so index 0, 1, and 2, and then items 8 and 9. So to do that, we can do something called concatenate. So I'm going to call this the concatenated array. And there's a function within NumPy called concatenate. So it's NumPy. This is the documentation for it. So I'm going to copy it so I don't have to spell it. And this says how we use it. So A1 through A2, these are the arrays that we want to concatenate. And notice that we have to put parentheses around those arrays. We might talk a little bit about axes later, but 0 is kind of the default. It does the thing that we want it to do, where we just put them together. We just smush them together. We have to start worrying about axes when we have multiple dimension arrays. Okay, so np.concatenate. We'll say we want the items. I think I said 1, 2, and 3. So this is going to be 0 to 3. This is going to remember, this is going to give the 0th indexed item, the first indexed item, and the second indexed item. Need to put parentheses around the array. And then I want the 8 and 9 items. So if I look at the 8 and 9, 8 is the 7 indexed item, whatever. And then 9 is the 9th. So I'm going to put, or the 8th indexed item. The 9th indexed item. Okay, so I'm going to put this. Sorry, 9 is the 8th indexed item, so I put a 9 there. And I need to close that, and then I'm going to print the concatenated array. And so when I print this, I should get an array that's 1, 2, 3, 8, 9. Okay, and that's exactly what I get. Okay, now NumPy can also do other things. So if we think about what we're doing in the colats problem, one of the things we're doing, we have a list of numbers, and we want to compute the mean of that array. So I can print np.mean of my array, and I get 5. So the average of this array is equal to 5. We can also do things like add them up, add the number of elements in the array up, and we get 45. Okay, and if you look at the various functions that NumPy can do, so here are array manipulation routines, meaning ways that we can concatenate them, ways that we can sort them, all those sorts of things. We also have a bunch of functions that we can do as well. Oh, here we go. Sorry. So maybe like statistics would give us, nope. Yeah, okay, sorry, yes. Statistics, we can do mean, average, and so on and so forth. Median. Now here, for average, we can compute the weighted average. And this is just the normal mean. So that's what we use there, and so on and so forth. Okay, and there's all of these other operations that we can do to them as well. Now, one very cool thing that we can do, one of the reasons that people really like NumPy, is because we can do things to them. We can do things to NumPy arrays in a much easier way than we can manipulate arrays in other languages. So here's what I mean. So I'm going to introduce a new array. It's going to be called the square array. It's just going to be, all I'm going to do is I'm going to square every element in this array here. So the element should be 1, 4, 9, 16, 25, 36, 49, 64, and 81. So just the first 9 squares. Okay, now one way would be to do a for loop. So I could say square array is equal to NumPy 0. I'll just make a blank array of zeros of length 9, and I could say for k in range 1 to 10. There's various ways I could do this. SAR of k is equal to AR k squared, like this. If I run this, oh, sorry. See, I have this indexing error. So this is one reason not to do this. So range 0 to 9. Whoops. 0 to 9. This is going to give you the numbers 0, 1, 2, 3, 4, 5, 6, 7, and 8. But now, do I have this right? So the kth, yes. So this is all right. So if I run this now, I'm going to get the square array. So if I run this, I'm going to get this number right here. So these are exactly what I should have gotten given the inputs. Okay, so for loops, this worked. Obviously, I made an embarrassing mistake there that you probably wouldn't make, but let's just get rid of this for now. So let's run this line, run this line. A much better way would just be if we could say SAR is equal to AR squared. Like this would be amazing if this would work. So I'm going to run this and look, it actually does work. And not only that, since we have integers there, it's giving us an integer output. Okay, so basically essentially every mathematical function that you can do on a NumPy array, and it does it element by element. So for example, if I want to look at the sign, I can do math.sign of array. If I run this, so NumPy, you have to use the sign in NumPy. If I run this, I get exactly what you think it should be. These looks like maybe they're the right sign values, and so on and so forth. Another thing that we can do is if I do AR to the power of AR, let's think about what this is going to be. Okay, so what this is doing, it's raising every number in AR to the corresponding value in AR. So 1 times 1 is 1. 1 to the power of 1 is 1. 1 to the power of 1 is 1. 2 to the power of 2 is 4. 3 to the power of 3 is 27. 4 to the power of 4 is 256, and so on and so forth. And there's other cool things that we can do as well. If I multiply these two together and then I run it, well, what do I get? I've just multiplied all the numbers. So this is 1 times 1. This is 4 times 4. This is 9 times 9, and so on and so forth. And then if I want to add them all up, I can do this, and I get 285. So in other words, I've just computed the dot product. On the other hand, I think I can just do, I've computed the dot product of AR with itself. I think this also makes sense. I get the same thing as well. See, there's a dot product inside NumPy as well. So if we didn't know that, though, we could try to come over here and search for the dot product inside NumPy, or just Google NumPy dot product. Okay, so at any rate, what I'm trying to show here is that NumPy is a very powerful library that works very intuitively, and it does basically all of the things that you would want it to do, which is incredibly helpful. So one last, well, that's all that I want to talk about for NumPy arrays right now. In the next video, I'm going to show how we can use a combination of NumPy arrays and functions to do the harder part of the homework that was from last week, or I guess it was due on Monday, where you're computing, doing a thing where you're computing the average of the terms in the collab sequence. Okay, but that's it for this video.